All right, in this video we're going to be taking a look at piecewise functions. The piecewise functions are functions that look like this. So functions that have pieces in them. So we've got some pieces that go on forever, some pieces that are cut off on both sides, and some pieces that go on forever here. You'll notice we have some open and closed circles. What they look like algebraically is this. So we have three sets of equations and three domain restrictions. And I've had videos on them already going over this stuff, but this is going to be a quick synopsis. I'll be doing these two problems, number 3 and number 4 from 13-1, 1 and 2 extra credit. And I'll be doing one of either 5 or 6, I'm not sure which one. All right, so let's start with number 3. Okay, so number 3 gives us 3 equations. Just so we're all clear on which equation I'm talking about at a given moment, I'm going to number them. This is number 1, that's number 2, and that's equation number 3. All right, so how you solve a problem like this is you take the first equation, 2x plus 1, and you take its domain restriction, x greater than or equal to 2. And what you're doing right now is you're trying to find some points that you can graph and then connect to make your lines. So what we're going to do is we're going to take this domain restriction 2, and we're going to plug it in to the equation. So I'm going to plug it in. So I plugged in 2. So that's going to be my x value of my coordinate. And I get 4 when I do 2 times 2. And then I add 1 and I get 5. So there's my coordinate. Then we look back up here, and this is a line underneath. It's greater than or equal to. So this is going to be a filled in circle when I plot it. So let's go plot it. 2 comma 5. 2 comma 5 is right here. And I'm going to fill in that circle. Now, I don't have any other points to plug in. There's nothing on the left of x like there is here for this one. So what I do is I look at the slope, and it's 2. So it's up 2 over 1. And I could do the reverse of that, down 2, back 1. So I have, if I was to graph this, this would be my line, right? Well, I need to figure out which side of this dot do I want. Do I want the one that's going to the right side of this dot that's going up, or do I want the side that's the left of this dot and going down? So I look here, and it says I want anything that's greater than or equal to 2. So here's 2 for my x-axis, and greater than's to the right. So I want the right side of my dot. So here's my dot, and the right side is this guy. So there's what I want. So I want from this point onwards to the right, going at this slope, up 2 over 1. For number 2, this is really easy. I don't even need to get a separate sheet of paper. It looks complicated because there's no x for you to plug in your 2 coordinate or your 2 numbers right here. But that's good because we don't have to do any extra work, and I'll show you what I mean. So I take that -1, just like I did for 2 earlier. I took the 2 and plugged it in, right? I'm going to take that -1. So I take -1, and I'm going to plug it in here. Well, there's nowhere to plug it in. So what happens when you plug in -1 is you just get what's there, and what's there is 3. So -1 comma 3. I'm going to plot that. It's going to be an open circle because there's no line underneath here. -1 comma 3 is here. -1 comma 3. Right here. Oh, and it should be open. I'm sorry. Open circle. Open circle. So big open circle. And now we're going to do the same thing for our second point. Well, when I plug in 2, I get 3. So now I plot 2, 3, 1, 2, and then up 3. And it's open circle. I remembered that this time. And I connect to my dots. I don't have to think about which way do I want because I have 2 points to connect. I've got -1, 3 and 2, 3, and I just connect them with a line. So those are both open circles and they're connected here. You'll notice this is a horizontal line, and that's what happens when you have no x value to plug in here. It's because there's no slope. The number next to the x is the slope in slope-intercept form. And so since there's no x, there's no slope, and no slope means a flat line, kind of like a flat hill would have no slope. Here, we're back to plugging stuff in. So I'm going to plug in that -1 here. So let me do that on a separate sheet of paper. So I take the original equation, 3x plus 9, and I'm going to plug in my domain restriction, -1. So I plug in -1 here. I'm plugging in -1, that's the first part of my coordinate. And what I get is the second part of my coordinate. So I get -3. And when I add 9 to that, that's going to be 6. So I get -1, 6. And I'm going to plot that. According to this, it's going to be a solid dot. It's going to be filled in. There's a line underneath. So -1, 6 is going to be filled in. -1, 1, 2, 3, 4, 5, 6. So all the way up here, filled in. And this says I want everything less than -1. So here's -1 on my x-axis. And everything less than that, right, it says less than, is to the left. So I want everything to the left. So I'm going to do what I did before. I'm going to look at the slope. Up 3/1 puts it here, right? That's to the right of my dot, so I don't want that. So I want the opposite of that. Up 3/1's there. So I go back 3, down 3, back 1, and here. So what I'm looking for is this line. Again, I did my slope. I did up 3/1 here and down 3/1 there to make my line. But I only want the left half of this line because I want x less than -1. Here's -1. Less than is on the left side. Let's try that again with number 4. So right away, I notice that this is going to be a horizontal line when I graph it. But I've only got one point to plug in. Okay, well, if I plug in -1 over here, since there's no x to plug into, I just get -2. And that's going to be a closed point because there's a line underneath. So I go to -1, -2, and I put that dot and I fill it in. Now I don't have another point to plug in. So if I want to make a horizontal line, I don't know which way to go. I don't have a nice, easy connect the dots like I did on this last one. Here's what I do. I look at the slope of this, which of course is 0, right? It's there's no x here, so there's no slope, so it's going to be a horizontal line. The question is, which way do I go? Do I go horizontal to the right, or do I go horizontal to the left? Well, I look here. I want everything greater than -1. So here's -1. Greater is to the right, so I want my horizontal line to go to the right. And I just kept drawing it as far as I wanted. For these guys here, you could also extend those out if you wanted, right? Just keep going, 3, 1, 3, 1, and just keep going because it's a line. This guy I just extended all the way out. If you did it really short, that's fine too. Looking at the second one, we have two numbers, so we plug them both in and see what happens. So if I plug in -5 for this one, let me scribble that out so we don't get confused. If I plug in -5 here, I get -5. So two negatives make a positive. I get 5 minus 1. Let me show you that. Take -x minus 1, and I'm plugging in -5, right? So when I plug that in, I get -5 minus 1. So I plugged in -5. Two negatives make a positive, and then 5 minus 1 is 4. So my coordinate is this. This is going to be a filled-in circle for both of these. So -5 gets a filled-in circle because it has a line underneath. So I do -5, 4, and fill it in. -5, comma, 4, fill it in. And since I have another point, I just repeat the process with this guy. So I got -5, 4, and I'm also going to get -1. Well, if I plug that in there, -x minus 1, I'm plugging in -1. Plugging in -1 here. Two negatives make a positive. 1 minus 1 is 0. So I plugged in -1 and I got 0. And it's going to be a solid dot. It's going to be filled in because there's a line underneath here. So I plug in -1, 0 to my graph and fill it in. -1, 0 is right here. I fill it in. And since I had two dots, one from this guy, right, -5, comma 4, and one from this guy, -1, 0, I can just connect them. So now on to equation 3, the third one. So I only have one number to plug in, so I'm going to plug that in. When I plug it in, I get -5, comma, let's see what happens. 3x plus 16, and I'm plugging in -5, right? Plugging it in. So I do 3 times -5 plus 16. 3 times -5 is -15. If I add 16, I get 1. So I plugged in -5, and I got 1. So that's my coordinate, and it's going to be filled in. -5, 1. -5, comma, 1. And I fill in the dot. Now this doesn't have another one to plug in, so I don't just get to play connect the dots like I did for this guy. I have to do what I did here. I have to check the slope and get some options. So 3 is my slope, so I go up 3 over 1. That's one of my options. I could also do the opposite of that and go down 3, back 1. See how this would make a line? So I have a question. Do I want to have the right side of this line or the left side of this line? So I look here. I want everything less than -5. So here's -5, right, where our big dot is. Less than is to the left, so I want the left side of that line. So here's my invisible line, right? I want the left side of it, so I want the part that's going down. And there's number 4. Number 1 and number 2 are extra credit. The only hard part about them is that they have some fractions in them, so just be careful with that. Be careful with that. Let's look at let's do number 5, I think. Let's do number 5. So now they give you the graph, and we want to make the equations. So what I do is I write f of x equals, and then I do squiggly brackets. And again, to keep things in order, I'm going to do 1, 2, and 3. You wouldn't do this normally if you're just writing this out as a mathematician. But so you know which equations I'm talking about, I'll label them. So now that they're labeled, I'm going to take number 1 first, and I'm going to write the domain restriction. I always do domain first. So let's scribble this so we know that's the other side of the problem. Let's do our domain restriction first. So for number 1, the domain restriction is how far it goes on the x-axis, right? We did that before. This right here is starting at -3. So starting at -3, here's -3. X is anything less than, because it's to the left. See how this keeps going to the left? So it's anything to the left of -3. So x is less than -3 is what we want. So anything less than -3. So I'm going to do this. X is less than -3. And because it's an open circle, I don't put a line underneath. And that's it. It goes on forever, so I don't need another number to cut it off. I just leave it like that. For our second one, we have 2 numbers that we need to write down. So we'll have a number on the left side and the right side of x. Here's x. For number 2, our left side number is -3, because that's as far as it goes on the x-axis. And then our right side number is +3. And so x is between those two. When we say between, we write our signs this way. X is greater than -3, right? Here's -3, greater is that way. And x is less than 3. Here's 3, less than's that way. So it fits all of the stuff in between -3 and 3. And that's what this line is. So we have this, and it's closed circles. We write a line underneath. For number 3, our domain restriction only has a left side to it. It goes on forever to the right. So we start at 3, and it's everything bigger than 3, right? Here's 3, and if we go further to the right, that's the rest of our line. So it's everything bigger than 3. So x is bigger than 3. So I'm going to write that like this. X, whoops, I wrote it the wrong way. X is bigger than 3. You could also write it like this. X is bigger than 3. Either way works. So I'm going to write it like that. And I go back and look. It's an open circle, so I don't have to put a line underneath here. I just leave it like that. No lines like this guy. And because it goes on forever in the other direction, I don't need to write any more numbers. That's all I write, is x is greater than 3. So I've done the 3 domain restrictions. Now I'm going to write the equations of these lines. So for number 1, it looks like we have a slope of up 1, back 1, up 1, back 1, or down 1 over 1, however you want to call it. So it's going to be minus x, down 1 over 1 is going to be minus x. And if we look for our y-intercept, we keep doing down 1 over 1, down 1 over 1, down 1 over 1. We'll find where we hit our y-axis. So let's extend this out a little bit. And you'll notice if we keep going down 1 over 1, down 1 over 1, down 1 over 1, we eventually hit here. So if we weren't stopped here, our line would keep going and hit there. So that would be our y-intercept. So our y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, minus 8. And that's the equation of this line. It has a slope of down 1 over 1, and it has a y-intercept, if you were to extend it, to negative 8. This middle one has a slope of up 1 over 2, right? That's where the first next nice point is, right here. Up 1 over 2. And if I keep doing that, it checks out, right? Up 1 over 2 fits this line. So I write that slope as up 1 over 2, rise over the run, 1 up top, 2 in the bottom, x. And then my y-intercept is right here. And if I'm going up 1 over 2, my y-intercept is going to be a half. So the y-intercept is a half because it's just above 0, the halfway point. And that's it for that equation. The third equation looks like it has a slope of up 2 over 1. So I'm going to write that as 2 over 1 or as just 2. So 2x. And then to figure out the y-intercept, I keep doing this, right? If I keep going up 2 over 1, I never actually hit the y-intercept or y-axis. I got to go over here. So I'm going to do the opposite of that. Down 2, back 1. Down 2, back 1. Down 2, back 1. So it would hit here if we extended it, right? That's where it would hit. And that's a y-intercept at negative 3. So I write that down. Slope of 2, y-intercept at negative 3. And that's the answer for number 5 altogether. You do the same thing for this one. I always like doing the domain first, just for practice, just in case you're wondering. Negative 3 and 1 is the domain of this guy, right? X is between negative 3 and 1. This is a closed circle. That's an open circle. So that's the 13-1 practice with piecewise functions. If you're able to take the graph and make the equations, and do the opposite, take the equations and make the graph, you'll be good to go for the quiz. Thanks for watching.